Challenge activity 8.1.1, hypothesis testing for 2 population means. It says it's a left-tailed t-test. A company would like to know if efficiency can be improved through a training course for employees. A sample of employees is taken. The time taken for an employee to complete a task before training and after training is observed. So that right there tells us that this is a paired t-test. The reason is we need to link one employee before the training to that same employee after the training. So we do need to compare those. And that's why it's important to know that it's a paired t-test. So here we have some results from Excel, and we're just going to pull those numbers from Excel. So we're going to go here first. We have our P, even though it says P, remember that should be P value. I noted that, I think, last week when we were looking at it, or a couple weeks ago. So our P value right here, P, is going to be 0.051, 0.051. Our test statistic is right here. This t-stat is negative 2.282, so negative 2.82. And now we need to find our n. We go up here to our number of observations. That's going to be 30. Oops, 30. Helps if I have it in the right box. All right. Our degrees of freedom, we see right here, DF, that is 29. Our point estimate before training, so we go here to the before column, and we see our mean right here is 33.1. And after is right here, 31.7. Let's scroll down. Let's go ahead and check. Nice little green check mark. We did it correctly. Let's go to the next. All right, an online math tutor service would like to claim that the average time spent taking a standardized test after students go through tutoring is less than the average time spent before going through tutoring. So basically they're saying that their tutoring will make it so that you can take the test faster. A simple random sample of students takes a pre-test, then goes through tutoring and takes a post-test. Results of the samples are shown below. So here we have the difference in sample sizes. We could not care less about sample. Well, we do care about sample size. That's not the right thing to say, but that's not what our test is trying to look at. The difference in 2 sample means. Not exactly. That's getting closer. What we're actually looking for is the mean time spent for all test takers before and after tutoring. Is the 2 sample hypothesis test a paired test or an unpaired test? Well, as we mentioned, this is a paired test. The reason that is that we need to link the student before tutoring and after tutoring, because you can have one student that just takes long tests in general. And if you don't make sure to specify that they're linked, your results may not be accurate. So this is definitely a paired t-test. Now we need to pull this from our results in Excel. So here we have confidence level is 99%. Remember the level of significance. We take 100 minus 99, that gives us 1, and then we need to convert it to a decimal. That gives us 0.01. What is the null hypothesis? Remember, the null hypothesis is always that the mean 1 is equal to the mean 2. Now, the alternative. This is where it gets a little kind of confusing. I think you need to make sure you know which is population 1 and which is population 2. So in this case, we're saying population 1 or sample 1 is after. So that means we're going to say that mean 1 is less than mean 2. That would be our alternative. Should H not be rejected, or does H not fail to be rejected? So look at our p-value is, let's go over here, it's 0.002, which is very low compared to 0.01, which means that we do reject our null hypothesis. When we reject our null hypothesis, we say that there is sufficient evidence exists to support the claim that the mean time spent taking a test after tutoring is less than the mean time spent taking a test before tutoring. So we check that. Nice little green check mark right there. Tells us we did it correctly. All right, that is challenge activity 8.1.1. If you have any questions about that or anything else, let me know.